All right, let's look at the homework 8.3, problem number 8. All right, so we want to find the centroid of the region bounded by these sine cosine curves. All right, so let's do that. All right, so we have, let's draw a picture first. All right, so I'm going to draw the y-axis here, and here's the x-axis here. Alright, so sine curve, let's say it's going to look kind of like this. So starting from 0, and it's a sine curve, so I'm going to just draw it kind of like that. Alright, and the sine of 2x, so it's going to be a pi over 4. So this is going to be right here. It's going to be when it's pi over 4. It's, oh, actually not that color, maybe. I want the, let's see, pi over 4 is going to be here. Alright, then the 6 cosine of 2x, so cosine of, let's see, 0, it's going to go up here, so that's actually 6 there. And then it's going to go down like that. Alright, so we know that this right here, it's 1/2 of that, pi over 8. So this is pi, over 8 there. All right. So the region we're looking at is the region right here. Right, and between 0 and the pi over 8. All right. So that's the region, and we want to find the centroid of that. All right. So first thing we do is find the area. All right. So area A is going to be integral from 0 to pi over 8 of, let's see, top curve is a cosine curve, so it's a 6 cosine of 2x minus 6 sine of 2x, 6 sine of 2x, right? Then with respect to x. All right, so let's find that. So we have, let's see, 6 is just a constant, and put it out here. All right, then let's find the antiderivative of cosine. So that's going to be sine of 2x and over 2. All right, then you have a negative sign. And the antiderivative sine of 2x will be negative, so it's going to turn into positive. And cosine of 2x and over 2. Then you're going from 0 to pi over 8. All right, then we can actually pull out the over 2 1/2 and incorporate that, so that's going to be 3 there. Because 6 times 1/2 is 3. All right, then evaluate it. So this is going to be 3 here. All right, so plug in pi over 8. So that's going to be pi over 4. So sine of pi over 4 is 1 over square root of 2. So we have 1 over square root of 2 plus cosine of pi over 4 is another 1 over square root of 2. And a minus, if you plug in 0, sine of 0 is 0. And plus cosine of 0 is 1. All right, so you're going to get, let's say, 3 times. All right, so 1 over square root of 2 plus 1 over square root of 2 is 2 over square root of 2, which is square root of 2. Square root of 2, and then minus 1. All right, so that's the area. All right, now we want to find the moments with respect to, say, the y-axis. All right, and I'm going to assume that since we're looking for the centroid, I'm going to just go ahead and assume that the rho is going to be 1, so we don't have to worry about the density there. All right, so this is going to be integral. Right, from 0 to pi over 8. So it's exactly the same, but it's going to be x times, so x times, right, and cosine of 2x. Actually, I'm going to go ahead and let's see, should I do that? Yeah, I'll just put the 6 outside here. All right, then you have a cosine of 2x minus sine of 2x, and with respect to x. All right, so we compute that. All right, so we need to use the integration by parts. Derivative of x is going to be 1, and the antiderivative of those guys would be, we actually did that before, so sine of 2x over 2 plus cosine of 2x. All right. So what you get is going to be, so you multiply these together first. So you're going to get, let's see, we still have 6. So 6 times, all right, x times sine of 2x plus cosine of 2x over 2. And then you're going from 0 to pi over 8, all right? And a minus, right? And then we have to multiply this way. All right, so we still have 6 in front. Then integral of sine of 2x plus cosine of 2x over 2 and dx. Right, and it goes from 0 to pi over 8. All right, then let's just simplify a bit. So we have a 2 and a 6 cancel out, so you have 3 there. All right, then we plug in. If you plug in 1 over 8, pi over 8 here, so you have pi over 8. Then sine of pi over 4 is 1 over square root of 2. Plus another square root of 2. So this is going to be, all right, so you have a 3 times pi over 8. So it's 3 pi over 8. Then you would have, so you plug it in. So you're going to have, let's see, 1 over square root of 2 plus 1 over square root of 2. So it's a square root of 2. So I'm going to put that here, square root of 2. All right? Then minus, if you plug in 0, 0 times anything is 0, so it goes away. So I'm not going to write anything down there. All right, then we have to take care of the second integral. All right, so again, 2 and 6 cancel out, so you still have 3. So it's going to be minus 3. Then we have to find the antiderivative. Sine of 2x is negative cosine of 2x over 2. And then antiderivative cosine is sine of 2x and over 2. Right, then you're going from 0 to pi over 8. Right, then we're going to just try to simplify. So if you plug in, again, pi over 8. So let's see, I'm going to go down here. All right, so you have, I guess, 3 square root of 2 pi over 8, right, minus 3, right? If you plug in pi over 8, so cosine of pi over 4, so it's going to be 1 over square root of 2 and divide by 2. So it's a negative 1 over 2 square root of 2. And plus another sine of pi over 4 is 1 over 2 square root of 2, right? Minus, and if you plug in 0, cosine of 0 is 1, so it's going to be negative 1/2. And the plus sine of 0 is 0, so that's 0. All right? Then you see that here, we can cancel these two guys because it's the same number with a different sign. So you have negative 1/2, so it's going to be simply 3 square root of 2 pi over 8 and minus 3 halves. Right? So we got that. So that's m sub y. And let's find m sub x. So m sub x, so moment with respect to the x-axis. Alright, this is going to be, remember that it's 1/2, and the integral is going from 0 to pi over 8. Alright, then you have to square the top guy, so we're going to square that. So it's going to be, let's say 36, so top of 36, and a cosine squared of 2x minus 36. Actually, can I just move out the 36 out here? Alright, so I'm going to put 36 here. Alright, that way we just have a sine squared of 2x. Alright, and then dx. Alright, then we know that this guy is the same thing as cosine of 4x. So if you take the antiderivative, you're going to get, let's see, 36 divided by 2 is 18. So you're going to get 18 times antiderivative of cosine of 4x would be sine of 4x over 4. Right? Then going from 0 to pi over 8. Alright, so let's say incorporate the 4 there, so it's going to be 9 halves, so I'm going to put 9 halves there. Alright, then you plug in 1 over 8, so 9 halves. Plug in 1 over 8, so pi over 8, so it's going to be pi over 2. Sine over pi over 2 would be 1 minus sine of 0 is 0. So it's going to be 9 halves. Alright, so it's a fairly long computation. But what we want to find is x bar and y bar. So let's find that. Alright, so x bar is going to be equal to, right? So all we have to do is take moment with respect to y, which came out to be 3 square root of 2 pi over, I'm gonna take a common denominator, so put 8 here, so multiply by 4, so minus 12, right? And divided by area, so we're divided by 3 times square root of 2 minus 1, right? So if you simplify that, you can cancel with 3 here, 3, and that'll be 4. Right? Then you would have, this is going to be, right, 8 is still there. Then you have a square root of 2 minus 1 on the bottom. Right? Then you have a square root of 2 pi minus 4. Right? And how about the y bar? Is take a moment with respect to the x-axis, which is 9 over 2. Then divide it by a, which is 3, and a square root of 2 minus 1. So we can cancel 3 and 9, so that's going to be 3. So you're going to get 3 over 2 times square root of 2 minus 1. Right? So let's type those guys in. Alright, so what we got was here. Let's see. We have a fraction here. Alright, so we're going to have a square root of 2. Alright, pi minus 4 over 8 times square root of 2 minus 1. Alright, and then y bar would be 3 over 2 times square root of 2 minus 1. Alright, so let's check the answer. Alright, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.